welcome everyone to another episode of Streaming Stories. Today's topic is Kafka, a new data lake. Sparked quite some discussions on social. We have been just talking about it before we started. And the opinions have been quite polarized. People were like, oh, it's not meant to be data lake, or they were like, oh, it's not even a question. One of the former panelists at Streaming Stories, Yaroslav Tkachenko, was like, it's not a question, like I'm using it as a data lake. So the discussion has been polarized, and we're hoping to get, by bringing like this amazing panel with very diverse perspectives, more nuanced answer to the question. So with us today, we have Richie Artul, co-founder of WarpStream Labs, Philip Yonov, Director of Product Management at Ivan, Alex Merced, is that correct?
That's correct. Alex Merced is 100% right.
Developer advocate at Dremio and author of book Apache Iceberg, The Definite Guide, and Yingjun Wu, founder and CEO of Rising Wave Labs. Welcome, everyone. Before we start, I would like you to briefly introduce yourself. Tell us where you're coming from, what you're building.
Is this a question to me? Sorry.
Anyone
Yeah, maybe I can start it because I already asked it.
So
Philip here. Yeah, Philip here, Director of Data Streaming at Ivan. Just a word about what am I doing in my day-to-day. I am delivering together with my team a complete data streaming platform, which basically allows users to stream, connect, process, and govern data. This platform is fully open source and built on Kafka and Flink, obviously, and a few other underlying components. Personally, for me, been working with Kafka since I think 2014. So that makes it, I guess, more than 10 years. So for me, you can say that I grew up with Kafka and data streaming. So that's pretty much me.
Okay, Richie.
Hey everyone, I'm Richie, CEO and co-founder of WarpStream Labs. What we're doing, we have building a product called WarpStream. It's a drop-in replacement for Apache Kafka. So you can think of it as a distributed system that behaves exactly like Apache Kafka does, down to the kind of wire protocol level, but has a completely different architecture than traditional Apache Kafka. Everything is completely object storage based. We don't have any local disks anywhere in the system, and it kind of separates compute from storage in the way that you would expect from kind of like a traditional data lake architecture. And the main benefits of that and why we're doing it is just to drive down costs and improve, make it easier to operate, easier to run, easier to scale. Before WarpStream, I was working at Datadog building out essentially another real-time data lake called Husky. That's was essentially a columnar store that stores all of the logging data at Datadog.
Thanks, Richie. Alex.
Hey, everybody. Again, my name is Alex Merced. I'm a developer advocate at Dremio. And now Dremio, what we're building is a unified lakehouse analytics platform. So basically a place where you can connect all your data sources across multiple clouds, across on-prem sources, be able to kind of curate them, govern them, query them, and deliver them to your different analytics use cases in a very sort of fast and affordable way. So that's what we're doing over there at Dremio. So I'll leave it at that. But we are going to be announcing some really cool new Kafka features over the next couple of months. So definitely keep an eye out in the Kafka space over there at Dremio.
Thanks. And Yingjun, your turn.
Hi, I'm Yingjun Wu, and I'm a founder and CEO of Rising Wave Labs. What we're building is a streaming database. Basically, you do stream processing and in a database manner, so that you do not need to understand a lot about the details about how we do stream processing. That checkpointing, you probably do not need to know that. We just need to write SQL code. So we actually have as a stream processing system, we actually have a pretty good integration with, let's say, messaging queues like Kafka, like WarpStream, like Repanda, like many others. And we also have integration with Iceberg, open data format like Iceberg and Data Lake, because people probably just want to probably consume data from data lake format, right? From S0, S3, reading in data lake format, or probably dump data into Iceberg, right? That's kind of common. So yeah, I'm super excited to join the talk, join the conversation, and to learn more about the game, and to discuss whether Kafka is a new data lake.
Okay, thanks everyone for the introduction. So just few housekeeping items, if Zach can go to the next slide. So you can ask a question, the previous one. You can ask question at any point, clicking on a Q&A button down there. The webinar is going to be recorded for everyone who asks, who cannot join. And if you have issues with Zoom, reach out either to Zach and me. Okay, so we can officially start, and I would suggest, given that our audience is very diverse and that for all the newbies out there, by clarifying what data lake is. Who wanna give like a short lesson? Couple of sentences. I feel like Alex will need to.
Yeah, no, this is actually a very big part of the very first chapter of Apache Iceberg, the definitive guide, upcoming book from O'Reilly. But bottom line is what a data lake is essentially one way to think about it. It's a big place where you can store your data and have basically all sorts of different types of systems access it for analytics. So traditionally, like basically data lake started with like the Hadoop world, where you basically have a huge distributed network of computers offering you sort of really affordable storage for all your structured and unstructured data, making it really easy to kind of access a lot of data. But oftentimes running the bulk of your analytics on there was very difficult. So you'd still oftentimes move a lot of that data into a data warehouse. But basically that data lake space has evolved quite a bit, because now you have data lakehouse table formats like Apache Iceberg, Hudi, Delta Lake that allow data on your data lake to be stored and recognized as different tables. You have different like sort of query engines like Dremio and Trino that can query that data and deliver what you need it. And then now, as far as like streaming options to be able to stream into that data lake, there's a growing world, which I'm sure we'll be talking about a lot today. But again, think of the data lake as basically that big hub where you sort of store all your analytics data, structured, unstructured, that can be accessed by a variety of tools.
Okay, thank you, Alex. Let's just like try to define what then streaming data lake would be, because Kafka is referred when we're talking, is it like possibly like a data lake as a streaming data lake? So what would be the most important feature of a streaming data lake, or like a data lake for real-time data? Who wants to go first?
Yeah, maybe I can actually take a stab at it, because I want to start from the top, right? I actually want to start from the data, not from the lake side. So it's all about the business-driven view here for me. And when we talk about data, it's always about intelligence and decision-making for businesses, right? Businesses want to make better decisions based on the data they have. And real-time data lives in the milliseconds and seconds. This is, if you come from the Kafka world, you know this very well. And this usually drives preventive, predictive, but usually always actionable decisions for the business. It is time-critical data which drives the very operations of the business, and we see more and more businesses actually built directly on top of real-time streaming end-to-end, like their whole operation is built on streaming. And now if you look at the double-digit seconds, minutes, hours, days, months, then we observe the reactive and historical type of decision-making, right? Or as we all collectively call batch, right? So for me, it comes down to the historical context of real-time intelligent decision-making, right? So can you actually combine the power of real-time with the historical context to make better decisions? Actually, now with AI, machine learning rising, we will be observing even like bigger need for, I call them internally low latency decision making, because you will need to equip the machines to make those decisions for you. Batch just doesn't really work, as the machine is always on. It can work with lightning speed, usually in milliseconds. It does not sleep. It does not take rest. Doesn't go to lunch break, right? So the notion of being able to have more autonomous business operation to begin with, to make those decisions automatically in the best possible manner, is quite exciting for me.
Okay. Anyone wants to add something?
Yeah, I think the thing I can see here that okay, like I mean, Writing Wave doesn't really do, I mean, data lake or probably doesn't really do, I mean, event streaming or messaging queues. But what we can see here that, okay, like a lot of people just, let's say, store 7 days data in their Kafka, right? Well, because a lot of data come in streams, right? Or like click streams or probably some other IoT streams, right? Well, these streams or these events are yeah, ingested into Kafka. And what we can see here, a common pattern here that people probably store 7 days data in Kafka, and then periodically they move the data from Kafka to some other, I mean, to downstreaming systems like probably S3, right? And they probably write into Iceberg data lake format like Iceberg Hudi and the Delta, right? And so the challenge here that okay, if we adopt such kind of pattern, I think that's one of the challenge here that okay, what if we want to do let's say a unified analysis on top of both the recent data stored in Kafka and the historic data stored in data lake. I think it's kind of pretty common. For example, in the crypto world, right? Well, or probably in the fintech world, they actually have the historic data, the trading data, and they also have the so-called the real-time data directly ingested from Kafka. How can we do analytics on both sides, right? So I think that's why I think that definitely there's some motivation about okay whether we can just store data in one place, whether we can just I mean so one possible solution is that probably we can directly ingest the data from Kafka to Iceberg or probably to some other data lake formats, right? Well, so that the only thing you need to query is the data lake, right? Well, is the Iceberg, right? Well, probably Delta or Hudi. But the other way is that essentially what we can do is that we can actually store all the data inside of Kafka. We do not do the data movement. We just write everything into Kafka, and Kafka can internally convert the data into, let's say, some data lake format, and then Kafka can be the data lake. I think that's probably the one of the biggest motivation about okay whether we should consider just using Kafka as the data lake. So yeah, that's what I can see from the I mean, stream processing manager, which does not really do, I mean, event streaming and doesn't really do, I mean, do the data lake things. But I think that's definitely about well, okay, whether we can reduce the data, avoid the data movement, it just do analytics in one single place. Yeah.
I think I agree with a lot of that. I think for me, the biggest thing that would make, something or a real-time data lake is just having all the power and flexibility of a traditional data lake in terms of queries, but essentially having your data always be really fresh. So, if you're thinking about it in terms of like for example, like what Rising Wave does is gives you essentially real-time views and SQL queries over your data. And if you look at it from the kind of Iceberg world and open type table format, I think that the kind of stream-like version of that is like if your Iceberg table can be updated, let's say in under 5 seconds and always gives you snapshot isolation views, to me that is also kind of a streaming data lake. I think the whether or not that's built by like reading the data out of Kafka and then putting it into Rising Wave or Iceberg or Kafka somehow managing it itself. I think the end result is the same. Like what I'm not maybe not the result is the same, but the goal is the same of where you're just trying to get, at the end of the day, you want to be able to write SQL and have the results be reflect the reality as of a couple seconds ago, not a couple minutes ago or a couple hours ago. Um,
Alex, or if anybody wants to, maybe we can just like list the properties that Kafka is perhaps missing to become a streaming data lake.
I mean, to speak to that, online, some of the things are like just basically being able to have that sort of unified format that can be accessible and to have those more advanced sort of query abilities sort of built in. But kind of expounding on sort of like the iceberg bit, like the iceberg format is evolving in a way that probably a lot of this is going to be really possible. Like one of the big conversations that are going on in the iceberg space right now are different changes in what's referred to as like the REST catalog specification, which is an open API specification for how communicating with an Iceberg catalog can work. So theoretically, one of the proposals is to add this like scan planning endpoint that'll allow the tool to determine sort of how it scans the metadata, determines the metadata. So I can imagine a world where basically you send the query to Kafka, and then using that sort of connector, the Kafka can just take that data, translate it into Apache Iceberg metadata on the fly, and allow tools that would normally query Apache Iceberg to do that. So I think a lot of the pieces that are missing are just pieces that are just sort of on the verge of being developed. Kind of like this Apache Iceberg this scan planning, which basically makes it where you don't have to go to directly to the metadata file to kind of always get that Iceberg metadata, and that can really change a lot of things as far as who can deliver an Apache Iceberg type data.
Okay. Okay, thanks, Alex. Anyone wants to add on this? Just maybe less.
Just something to
like
focus just to focus the discussion here. When we talk about the data lakes, right, especially in streaming context, then we need to put front and center freshness, accuracy, ability to backfill, things which actually make those, this data available in the right time for the right people. And we actually talk about the platform, right? Kafka may not be the only piece of the puzzle. There are many pieces of the puzzle, but we are very fortunate to live in a time when actually these pieces are coming together to live that utopia where, real-time data is available in Kafka, yet it is, stored in object store for cost saving and cost efficiency, yet it is also query ready and fresh and accurate, and no engine is good at the end of the day, right? But rather this is driven by the business context. I think it's really what we are driving towards is a streaming data lake platform, if I can actually articulate this for the foreseeable future. Yeah.
Okay, and do you think that since Kafka recently introduced desired storage and persist cold data in S3, do you think it will have an impact? Someone is nodding or disagreeing already. How that will have an impact or not in Kafka evolving into a new data lake?
Yeah, so I'm obviously super biased here, but I think tiered storage is not the answer for getting a real-time data lake out of Kafka. It's just I think tiered storage is a great optimization basically for reducing storage costs for existing Kafka clusters, using Kafka's existing architecture. But fundamentally, the way that data is organized in Kafka is at odds to serve the Kafka protocol is at odds with how data needs to be organized to be a good data lake. A good data lake gives you data that's structured. It's sorted by keys that match kind of the predictability of your queries. I'm sure, Yingjun can talk about how Rising Wave organizes the data and optimizes for various different query patterns. Whereas tiered storage is very much optimized for an individual broker to be able to load in batches for a specific partition really quickly. Even the fact that even if you move the tiered storage implementation to be the files themselves are Parquet and it's columnar, it's the data locality is all wrong. And so I think actually to have, if you want to be able to consume something as Kafka and also have a real-time data lake, I actually think you need to have two distinct views of the data. In which case the tiered storage for Kafka thing is really just a cost optimization for storage. That's my, I don't know if everyone agrees with that, but that's my kind of personal take on tiered storage.
Yeah, I'm very biased here, so I'll jump very quickly because my team actually contributed to tier storage on open source. And I would say that actually what Richie is saying is correct. We need to take a step back and understand what tier storage does for Kafka. What problems does it solve, right? So there are 4 problems with tier storage. With Kafka, and how tier storage solves them. It's sizing, number 1. So you can only infinitely scale a broker until it falls apart. So adding tier storage or object store allows this kind of decoupling of the compute and sizing of the Kafka cluster, elasticity, right? So that you can actually be able to more dynamically operate the cluster, expand or shrink it, because you will be actually balancing less and less data, hopefully, if you tier correctly. Fault tolerance stems from these 2 facts, actually. If you balance less, you're less vulnerable. Ergo, maybe you will be able to survive an issue. And last but not least, of course, cost, right? Those local disks are expensive. You can actually definitely offload, but tier storage was never meant to drive data lake into Kafka, right? To begin with, it solves very acute, very concrete pains for Kafka or Kafka users at any scale.
Thanks, Philip. Injun, Alex, want to comment on this?
Think I have anything to add on this one.
Injun?
Oh, okay. So I think for the so definitely tier storage is for yeah cost saving, right? Well, because like if you store all your data into in let's say local disk would then definitely be super expensive because well, I mean if you actually have to have the EC2 running around you, and the EC2 is definitely way more expensive than S3 for sure, right? So I think what the idea of the idea of tier storage is that okay, look, we probably don't really need to have store all the data into, let's say, inside of the your local disk. We can definitely dump the data out there out to S3 so that you can reduce the cost, right? So and I think for Kafka to become I mean, let's say if we want to have Kafka to become let's say a unified data storage where we are so-called a data lake, I think one of the challenge here is that um look, well, the benefit of data lake like Iceberg, right? Well, I think one of the biggest benefit is that it actually allows all the data, all the engines, all the systems, no matter whether it's, let's say, RatingWave, Spark, or ClickHouse, or whatever, right, to access a single source of truth, right, to access one single copy of the data. So that you can probably do machine learning, right? Well, I'm not a machine learning expert, probably, but you can probably can use directly access your data using TensorFlow or probably some other systems, right? You can use all the system to access the same single copy of data. So it I think it totally makes sense. Yeah, I think what definitely tier stores would not make Iceberg or Kafka like data lake. You still need to write into some open data format like Iceberg so that okay everyone can know okay look, this is how data looks like. I can just read and write data using the same protocol, right? So I think what definitely there's yeah definitely there's just we definitely need to do more than just I mean adopting a tier storage, but definitely there are some in terms of cost saving. I think we're definitely we probably have some other questions about okay how the let's say the warp stream architecture is different from the tier storage, right? Where we can leave it to into yeah, a little bit there. And but in terms of the iceberg thing, I think one of the challenge we probably also need to I think we're definitely one of the challenge we also need to think about it that okay if we want to introduce write data into iceberg, right? Well into iceberg format, then who do the compaction, right? Well how we manage the data compaction, right? Well that's definitely a big part of the data lake, right? I think definitely Alex can come on more on that part. Yeah.
Alex?
Okay, cool. I mean, one thing I can say is about bottom line is probably as far as like again the practical like how you probably execute using Apache Iceberg inside of Kafka. I mean, that would depend. And then again, it doesn't even have to necessarily be Apache Iceberg. It could be some either like some newer format. Like there's like another one that's called like Apache Pymon that came out of like the Sling project. There could be some other format that just makes sense. And I saw there's a question about one table, and one table can be sort of a unique tool for solving the sort of metadata solution problem in the sense that what one table is, it's a sort of metadata translator that allows you to translate from Iceberg to Delta Lake. In the future, it could add other formats. So Kafka could come up with its own format that does kind of address a lot of the issues that Richie mentioned, part like look that really takes into consideration things like locality of data and the right kind of keys or whatnot to have the sort of the right setup for the data. But then using a tool like OneTable can then translate the outward facing metadata in a format that's like Iceberg, Delta Lake, Hudi that could be used by a query engine that expects those types of formats. So there's different ways that could be executed, but those are just some of my initial thoughts.
Thanks, Alex. Anyone wants to add something? No?
Maybe I can list actually a bit of the problems with tier storage and why we need actually to start thinking a bit more in terms of how to understand what it actually is needed to start thinking in terms of lake mentality there. So first and foremost is the most obvious one. Kafka works in rows and the data lake speaks columns, right? So who is going to pay the transformation tax? To Richie's point earlier, right? We need to find a way to kind of seamlessly transform the different data types to tune it for the lakehouse formats. Usually, from what I've seen, you're always writing on Kafka, but on the lake side, there is always somebody reading it, or there is some engine reading something, right? And this is where the compaction problem is. It's a small files which are coming in fast, and then you need to compact to optimize for querying on the other side, right? So these types of I call it the separation of concern, right? Needs to be established on a very low storage level almost, right? To actually make it effective. And another point, I think, Richie, we talked with you several months ago, but this reminded me, schemas on Kafka are not your schemas on the lake. Data formats, collision, and all sorts of incompatibility might be a nightmare, right? So being able to handle proper schema management end-to-end is something of a challenge today. And I believe that it will be a very big topic for our unification journey going forward. Yeah, these are just some of the high level things which we need to kind of consider when we talk about those things being unified.
May I ask a question? How do you handle this problem in Ivan's Kafka?
We don't. Schemas for streaming stay in the streaming domain. And if you want to drive, let's say, a workload towards your data lake, we count on you that you will be actually handling cataloging and metadata management completely separated. So we do not have any eyes on this. For now, today, we provide a number of connectors which can offer offload to the data lake from your streaming environment, but this is where we stop. In the future, we are considering something really cool. We are trying to teach Flink, for example, to fetch the data directly from tier storage segments from the bucket, so not to fetch it from Kafka. But this is a very early project for us, but I think it's a very interesting idea, at least.
Yeah.
Thanks, Philip. Shall we move forward with the questions? So let's explore for a moment like how Kafka stands against existing data lake managing frameworks such as Apache Iceberg and others like Hudi and Delta Lake. Alex, want to make a comparison?
Yeah, I mean, I guess in its current state, I mean, they're architecturally kind of solving different things. So like when you take a look at like Apache Iceberg, Delta Lake, Apache Hudi, they're essentially collecting a bunch of metadata that's oftentimes stored on your object storage or your on-prem storage that allows an engine to understand the files that are on your object storage. Now, in the case, with Kafka, you're not storing the data in any of those formats and necessarily having that same sort of metadata relationship in a way because it's solving currently a different problem. Again, it doesn't necessarily mean that architecturally can change, or there could be sort of external layers that provide some sort of abstraction like that. But I would say, I guess it depends on what you're doing. Like I think if you're creating like your traditional data lake where you want to have a bunch of different tables that you then catalog and people can easily access and see, so that way it feels more like a database or a data warehouse, oftentimes anchoring on one of those table formats, I feel like oftentimes is sort of a good default. But again, in the I could foresee a future where again, there's different ways to take advantage of those standards in use cases that aren't necessarily from tools that aren't like that's where it isn't the case today.
I think like another problem that you kind of started to highlight on there and like why it like kind of doesn't really make sense, at least with like the architecture of like traditional Apache Kafka, to try and treat it as a data. I know people use it as a data lake in the sense that they like retain data forever and they treat it as like a historical source of truth, which I think is very different than using it as a data lake. And you were talking about like centralized metadata there. This is also like one of the reasons I think like trying to use tiered storage as a data lake format is so fraught kind of with peril. is that like one of the defining implementation details, it's not a characteristic, I would say, of how modern data lakes work, is there's usually some kind of centralized metadata storage, whether that's in a database, like the way it works with Snowflake, or whether it's in, the S3 files themselves, like it is with Apache Iceberg. But effectively, what you need is the ability to perform essentially like centralized compaction planning and then atomic updates of many different files that are in the object store and essentially treat the entire system as like one thing. Whereas when you look at like Apache Kafka's architecture and how tiered storage is implemented, it's essentially like each topic partition is its own thing, and there's some broker or node that is the leader for that topic partition is responsible for managing that data. But when you're dealing with a data lake, you need to take like a global view of the data, um, because the end user doesn't care about partitions at all. What they care about is like this table and the entirety of that table, which may be split over many, many, many topic partitions. And so, kind of Kafka's model of like thinking about topic partition leaders, um, it just becomes very difficult. For example, the thing you're talking about, Philip, where you like trying to read the segments for tiered storage out of S3 for Flink instead of having to go through the Kafka brokers. It's a very like good optimization basically to be able to stream the data into Flink faster. Um, but once you start doing that, basically the brokers can't really compact the data anymore or like reorganize the data because someone else is now reading it right from that format without going through a centralized metadata layer. And so I think that's like kind of one of the central that's maybe another defining characteristic of like a data lake and a streaming data lake is the ability to treat um, the system as kind of one logical thing at the metadata layer.
So I think today the whole point the whole thing the key thing we're discussing is actually should we essentially combine two different systems together into one. That is, well, should we combine, I mean, Kafka with let's say data lake or probably write data in directly in Iceberg format, right? So I think I saw that way in the comment in the chat box, and someone commented that okay, essentially Kafka is for ingested data at very high volumes, while the where the data lake is more for the stored data in cost-efficient way and access the data efficiently, right? And there's also reason we get rid of monolith application because, well, I mean, different Kafka is for something and for some purpose. It's built for some purpose, while the data lake is for built for different purposes, right? I think today we're discussing that okay, whether we should let's say essentially there's one question that we haven't answered it that okay, should we have just one monolith application data stack of just one single system that fits all, right? Well, I think the answer is that okay, as a definitely I don't like I don't really think that okay, we should just have one single system, but I do think that it definitely there are some use cases where the Kafka can be a data lake. I can give you one single example that is trading, and stock trading or probably crypto trading. The thing here that okay, because well, for these guys, well, most of the data, or probably almost all the data, is actually ingested from Kafka. They don't really have any other data sources. They probably don't really have any like directly dump the data into S3. There's no CSV for these guys. Well, all the data, a batch CSV for these guys, all the data is ingested into Kafka. So their pipeline is kind of simple. That is okay, Kafka, stream processing, and then data lake, and then probably add a DuckDB or probably ClickHouse to do real-time analytics on top of the data lake. But essentially, when I talked to these guys, well, they told me that okay, can we just use one single system to handle everything in one single place? Because well, I only have the streaming data from Kafka, and I don't really need and I think well yeah, and I in my mindset, I mean in this guy's mindset, if it's more natural to think data in a streaming way because there's no batch data. all the stock data, all the trading data are streaming data, right? Well, so that's what that's your opinion, and they think that okay, Kafka can be a data lake, and I think well, they definitely that's a huge gain for them if we just directly turn Kafka into a data lake. But for some other use cases, like I don't know, I mean, like machine learning, probably some other traditional use cases, like okay, I just want to build a, let's say, a financial dashboard, right? For financial analytics, there's a lot of batch data. Probably the data coming from different sources, not just Kafka, but also some other applications or some systems. Then I definitely agree that okay, Kafka probably cannot just be the single system to store all the data. And yeah. So here's my opinion about okay, whether Kafka should be there should be just one single monolith system.
Anyone want to comment on this? Different use cases.
I have a provocative point here about the organizational aspect of all this.
Mhm.
It's about positioning of the streaming system and the architecture of pretty much any company. The Kafka ecosystem usually lives in the operational domain of a company. It's very rare actually to see a crypto trading company which is the system. It's the brand new breed of companies which are becoming native to real time, but usually the vast majority of companies are actually having streaming in their operational domain, right? And think of it like this: there is a high chance that Kafka lives in engineering department, and people without GitHub account rarely, if ever, interact with it. So what this means is that organizationally speaking, there is a divide between the business operations and the business analytics, for example. The business people who work traditionally and more actually with AI, machine learning, decision-making scientists actually work with a whole different ecosystem, and it is very unusual with them today, right, to work with streaming data directly. Usually they work with after-the-fact data, right? Something which is stored somewhere, and they can run their batch jobs on this. So for actually Kafka to become more and more of a data lake, right, it needs actually to mature its positioning as well and graduate out of the engineering department. And I really cherish every example where actually the whole company is a streaming pipeline, because this could be the model of the future. If you want to look at what companies will be doing in 5 or 10 years, look at the big technological giants like Uber or Netflix. Especially Uber is a very good example where data freshness is a business requirement across the board. So yeah, that's my opinion. It's a bit controversial, right? But I think it could be something to add to the discussion.
I think that's go for it.
Go ahead.
Alex.
Oh, okay. All I'll just say is like one that I thought that was like a great point. And then also I think there's like the dichotomy of whether Kafka should be a data lake versus the data lake, in the sense of having sort of like one big system that's just one big central point of failure. I don't think any system anywhere should ever necessarily play that role. As definitely a big proponent of like data lakehouse architecture, which is essentially trying to move away from sort of having too much in one bucket and have a composable data system. For very much for that reason, where you can kind of swap things in and out as needed. But I think, but if in a world where sometimes you might have multiple data lakes for different use cases, having Kafka as a data lake for certain use cases definitely, I think, can make sense for the right use cases versus it being the data lake, the central system for sort of all use cases.
I think some of this too is just about like, for example, like some of this I think is just about whether or not, like basically today, if you want to do streaming, you have to like grab Apache Kafka or pay someone to run it for you. Then you have to grab something to do streaming compute for you. And then you have to potentially also integrate that with whatever data lake solution you're using as well. And I think maybe, some of the desire to use Apache Kafka as a data lake, I think, like you guys are saying, just comes down from wanting to reduce the number of systems. But I don't know if the number of components like at the lower levels really matter so much as like presenting to you end users something that looks like unified, if that makes sense. Like you can imagine a streaming data lake that uses Kafka as one component and using Rising Wave as the the kind of query engine and materialized view component, and then wrapping that up into a product where people don't have to think about the underlying fact that there's a Kafka cluster there somewhere. Avon is, Avon having both Apache Kafka and ClickHouse and Flink under one umbrella kind of gives them the ability to kind of do that. The way WarpStream thinks about this problem is basically allowing you know, our software that is exposing the Kafka protocol to also generate a separate view of the data that is a kind of streaming low latency Apache Iceberg table. And so I think a lot of it too just boils down to like how hard is it to stitch these things together, and can you offer kind of a seamless product experience? Um, and so whether or not it's like Apache Kafka, the open source project that does this, or it's some combination of things, um, I think to Philip's point, the thing that kind of matters in the end is like, can you get people, the data scientists and people on the business side, running queries against something that is updated really incrementally? Because they're probably not going to write Flink jobs.
Let me add one more comment. Well, so essentially, what we can see here that in most of the I mean enterprises or mid-market companies, well, I mean these guys will do not really have do not consider streaming as the only way where data comes from, right? Well, they actually most of the companies will actually come from dashboards. They actually have that first, and then they introduce the streaming. Okay, they think that, okay, whether I can turn some business into streaming, right? So that's how they think, but at the same time, what we found is that in some new companies or startups, especially startups, early stage startups, they think things. Well, I mean, they think questions, problems differently because they and for some of them will think that, okay, whether I mean, because my data is probably just like generated from IoT devices, or probably my data is generated from, let's say, the blockchains, right? And can we just use one single unified system, right? And in this case, to be honest, well, I think, well, I still think that, okay, Kafka is a single system. I mean, like as a data lake, totally makes sense because, well, I mean, they only have one single or one type of data, right? Well, or probably it's just one type of data, which is the blockchain data, probably the OT data. But at the same time, I do agree that, well, as this company grows and let's say they turn into, let's say, a group Series B or probably Series C company, right? Well, a larger company, they probably will also need to I mean, get more data, analyze the batch data. For example, they probably think that, okay, I mean, the on-chain data is not enough, right? Probably I also want to buy some data from some people, from some vendors, so that, okay, I can analyze the traditional data, historical data. And I think, well, yeah, I don't know. Well, I mean, for these guys, well, should they just use Kafka in the future, one single system in the future? I don't know that. I don't really have an answer, but I do believe that, okay, in the future, again, well, I don't really think that any system can. There's some system can be called as, well, one system fits all, right? Well, there's no such kind of system, but there are definitely vendors that can provide a unified view. So that, okay, I mean, like, well, in WebStream, right, well, they build something like I mean, like modern Kafka, right? Well, I call it modern Kafka, but essentially they can have let's say, provide a view, I mean, let's say a lakehouse view or something like that, right? So that, okay, the customer or the user can just access their cloud and do everything in one single system. I think that's definitely, that's probably viable, right? Well, that's definitely doable. Yeah.
Okay.
I think we have already the platforms which provide you to stream, connect, process, right, and govern. Govern is still questionable, but let's say, especially on streaming, we're pretty okay. You know, Kafka is a solved problem when it comes to like buying and choosing a streaming platform for your business, right? That's something which is already on the market, and you can buy it in many different shapes and forms. What maybe you can actually add to the mix here is the ability to materialize and create certain products on this data, or let me call it like this, productize the data, right? So if you are able to stream, process, govern this data, and then eventually be able to build on top of this data, this is one of the good ways actually to start democratizing the stream to, you know, non-technical users. That could be a potential way forward. And then it can actually have data lake capabilities, not being like a full data lake, right? Or fit the model, but still have, you know, the goodies like, for example, infinite extensibility and cost effectiveness.
Thanks, Philip. We have not so much time left, so just like a few more questions. So one of the questions that I wanted to ask you for the end is, are we at the moment like good enough to put together existing products for streaming data lake? More specifically, is schema registry good enough as a unified catalog for streaming data?
That's for sure for Philip, I think. I don't know.
I'm smiling because the answer is most likely no, but it's the most potential there. Because I mentioned in the beginning, freshness from the, you know, from streaming lake point of view is just one dimension. Accuracy is the other one, right? And, you know, schemas and proper schema management end to end from the source all the way to the downstream users, right? Whatever they may be, and consistency of data and making sure that you actually have a proper traceability and making sure that you have proper, let's say, trace back to the source and understanding of the source and understanding of the meaning of that data is becoming super crucial, especially if you want to turbocharge the experience of building those data products on the stream, right? So I think that currently today, the schema registry of today are not prepared for those requirements, but at the same time, the potential is there to actually elevate the experience because this is your data model, right? What the schema registry actually solves, it's the data model for the stream, right? And if you have the data model for the stream end to end, from source to destination, this is something very powerful.
Anyone wants to add something? Can I abuse my role as moderator and asking just something? So given that Rising Wave supports both storage, catalog, and stream processing, is Rising Wave a streaming data lake?
No, definitely that's not. No. I think definitely the answer is no because for the again, well, I mean, Writing Wave is more for the, I mean, for stream processing. It doesn't really, I mean, it does to store data, and we do have integration with Iceberg, and for sure, and we do have integration with I mean, Kafka, WebStream, whatever, right? But the thing here that I think it's more about building an ecosystem. I think that's my view. Because again, I don't really believe in the also called all-in-one system. I don't really believe that, but I do know that key. I mean, as a vendor, from the vendor's perspective, I definitely want to provide all-in-one system, but that's just my dream. The reality is kind of different because I cannot do everything in one single system, right? Well, Ivan probably can, yeah, it can commercialize all these kind of systems, but well, I mean, essentially, I mean, it's really hard for one single vendor to innovate all these systems. It's more about collaborations. It's more about it's more about okay, how we integrate with our other systems, right? Well, I think someone mentioned okay, one table, right? So essentially, that's a pretty good example about how we solve this problem. Because well, look, we have Iceberg and Delta and Hudi, right? And I do believe that definitely every single data lake format have their own pros and cons, right? And definitely if this, I mean, if we can have one single system that can help us to translate the data format, then for sure, I mean, it can make us our life much easier, right? And again, well, also I definitely mentioned that the vendors definitely want to provide a unified view so that I mean, it's like okay, all in one system, right? But well, it's also pretty yeah, it's also there are a lot of challenges we need to address, right? For example, if you manage all these different systems in one single, let's say, a bigger system, then you actually need to think about like how I can address the correctness problem, how I can guarantee the, I mean, fault tolerance, right? Well, like what if one single system failed? Let's say Kafka failed, then what I should do, right? Well, it's a downstream system, what I should do, right? If it's easy, I think, well, then Ivan will provide a big one single, well, I mean, all-in-one streaming data lake immediately, probably in this year, if that's simple enough.
I'll stop Yingjun here. We have a bunch of questions. Like, do we have a final verdict on this question? Is Kafka a data lake? Yeah. Okay.
Okay. Well, I think I would like to ask Philip, why not? I mean,
Very
can
quickly.
provide one single system lateral? I mean, streaming lakehouse instead of selling different pieces.
It's very simple because it's so many people needing to actually come together with different skills from different angles, right? Because if you want to provide a full experience end to end, right? In the world of data streaming, and Richie knows very well, we're talking about milliseconds, seconds. This is like the dimensions we think about. In the world of data lakes, you guys know better than me that we are talking about freshness, relevance, much more sophisticated schema management, metadata management. Our world in the streaming domain is fire and forget. Data is just, high in volume. Relevancy is sometimes questionable depending on the workload. So if you want to provide this, let's call it a cohesive product end to end, right, which has all the goodies, then the lift is massive. And at the same time, the turnout is uncertain. And this is especially because what I already started. And there are three huge problems before, I wrap up my conclusion. First of all, streaming data is still very expensive data. Compare it to S3 calls, for example, it's 10x. It's just expensive. Richie's company is solving this for all of us, right? But it's still there. The cost is there. Second, it's still very hard to set up and run, and it's also using aging design, and it's still not fully cloud native, despite all our efforts and everybody else's efforts in the community. And last but not least, as I mentioned, business users just do not work with streaming data. They work with after the fact data. Streaming is confined to operations, right? So if we start solving those problems, which I mentioned, I think that we will see the platform coming together automatically.
But I think Drew will try to solve this.
Yingjun, like you'll continue this discussion with Philip next time.
No. I mean,
2 weeks.
yeah.
We have to move to questions.
For Alex,
We have to move to questions. We have a lot of questions. Please open the Q&A tab. Who wants to go first? What do you think? Like, shall I read, or like whoever feels that's their up their alley can answer the question? The first one with one table.
Yeah, one table we have already answered.
Alex,
but I think Alex.
Yeah, I'll just quickly summarize it. Again, I did mention this earlier. So bottom line, one table allows you to translate metadata from one format to another. It opens up some new possibilities. We'll see what those possibilities are in the future. So I'll leave it at that.
Okay, the next one. Can you comment on data formats and supporting indexes needed to have real-time analytics? Also, how they're harmonized with what will be sorted and on disk and available for later batch style processing.
Yeah.
I can talk about this a little bit because I was talking about the different file formats and stuff, but like the primary thing that you need to make a real-time data lake good and fast is the data has to be in columnar format. There's just like no choice about that. Like just row-oriented formats do not scale or perform. So you have to have the data in columnar format, and ideally you can materialize every column fully. And you're not, just shoving JSON blobs into giant columns and then trying to parse them at query time. You need really good kind of I usually call them I forget what the exact term is, but things like skip lists, and things that allow you to skip over large chunks of data quickly, and you need the data to be essentially sorted and partitioned in a way that optimizes for most of your queries. So, for example, the kind of common time series data lake situation. So if you imagine what Datadog does to organize your logs, data is partitioned by time, so that when you're searching for logs in the last 1 hour or 30 minutes, you're looking only in a subset of the files and not all the files. And these things are kind of fundamentally at odds with how the data has to be organized in Kafka to answer essentially live consumers. And yeah, I think that's a good summary.
Yeah.
And I hope this was the answer to your question. The next one, who wanna take the next one?
I think there's one more question which is pretty interesting, that well, can data lake be the next generation of streaming platform? This is a reverse question. I think well,
Yeah.
Alex, I don't know. Yeah, who wants to answer this question?
I have another provocation to make. What if we start thinking in the direction that the data lake is maybe not a data lake, but a data river? And it's just, about the upstream of the river where latency is very low, like, the upstream is very, quick waters, and the bigger the river grows towards its delta, the slower it gets, and the latency gets higher, right? But the depth is also higher, the volume is higher. So that's my philosophical answer to this question. Could be.
I definitely like that. And at the end of the day, like, what's a data lake? I mean, it's kind of like beauty is in the eye of the beholder. I mean, beholder. A data lake is in the eye of the data engineer. But at the end of the day, what we call things nowadays, with everything kind of bleeding into each other, doesn't matter if it doesn't solve your use case. So the question always first is, what are you trying to do? And then use the tools that serve the thing you're trying to do, and you'll always end up in the right place.
Anyone wants to take the one on KSQL DB? It's a long one. The next one is, are you aware of anyone who uses Kafka as a Delta Lake in production? Goldsky?
Yeah, they do use it, but I think the way they use it is like, and I think this is what people mean when they say they use Kafka as a data lake. My understanding, and maybe he'll comment later on Twitter or something. I don't know if he's watching. Um, but they use it as like the source of truth, right? It's a historical record of all the events that happened, and that allows them to replay all of history from the beginning of time, which is a very, very useful property. But I'm sure they're also materializing that data into views that they can actually query to power their product. And so that is the situation, I think, where Kafka serves well. If you enable infinite retention, you can have essentially a permanent record of all of history in kind of time order. But I think that's very different than what most people mean when they say like we need a data lake.
Yeah.
Can I ask you to stay a few more minutes? If someone needs to leave, please go leave, just to address some of these questions. There are compelling business reasons to make Kafka the data lake. Setting aside the technical reasons, what are the downsides for the business application?
Oh, sorry, go ahead. Sorry, go ahead.
Oh no, I was just gonna say this. I was just going to reiterate the whole single point of failure thing. That's it. So go for it.
Complexity. Business users don't work with the stream. Again, I'll keep repeating this. And if you want to do streaming data lake, those business users need to learn how to work with the stream, or at least be having the tools to work with it. So it's not about really technical reason. It's about organizational/perception reason, right? Kafka needs to escape, or streaming data needs to escape actually the operation domain of any company.
Mm-hmm.
Thanks,
Yeah.
Philip. Who want to take the next one? Kyle Veller. It's a commentary/question.
Kyle made us read.
Yeah, I mean, and I think what Kyle is describing here is multiple systems working together in harmony to present as a more unified data platform, with different materializations of the data for different use cases. And I think it's a good summary of some of the stuff we talked about.
And Andrew
I don't know
Mills.
if there's really a question here, actually, like you said.
So somebody asked, so we're going back to a chat, like, can we talk about Flink versus Kafka connector ingest data to data lake?
I can give you my high-level opinion on this. Kafka Connect is one of the best row to column converters out there. It's what it was designed to do. Flink can do this as well, right? So whether you use this or that, it's almost down to preference and of course contextual business requirements, right? And how you want to actually run your data streaming. But other than that, I have no really preference when it comes to just, conversions.
Okay, I know I'm missing some questions in the chat. There are like a lot of
Yeah,
comments.
I actually have one last question. I mean, it is for Ricky because yeah, because I'm pretty interested in this question. Just I mean, just to give answer in probably 1 or 2 sentences. What's the difference between Warp Stream's solution and the tier storage solution delivered by in Cora and Repanda?
Yeah,
Just one sentence. Well, I mean, I believe
it's
definitely there are pros and cons, and please give
okay.
You
It's gonna
will
take me.
have- But you'll have him talk at Kafka. So
Yeah.
super.
It'll take slightly longer than 2 sentences. But the difference, I think, the easiest way to explain it is that, with tiered storage, you still have to basically, even if you only keep data on the brokers for like 100 milliseconds, and then you immediately copy it into object storage, and your tiered storage is like very, 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 very minimal. Until you make it so the brokers are completely stateless, you still have to deal with topic partition leaders. You still have limited ability to scale up and down quickly. You still have to deal with interzone networking, and you're still exposed to all the maintenance burdens of running a stateful system, because if there are any local disks involved, even if they're extremely, extremely short-lived, if you mess them up or lose too many of them, you've essentially corrupted the system. And so going from like there's 100 milliseconds or a second of data on the disks to no data on the nodes at all requires rethinking the entire system from the ground up. And that's where you actually start to see all the cost saving and operational benefits. And so, like I said before, tiered storage is a great optimization for reducing storage costs, but it's not a fundamental architectural change.
And last one, Alex, maybe you can take this one. Any thoughts about Kafka Iceberg conversion? Is sync connector the best option to achieve this?
I mean, I think right now, that sort of fulfills the role. I will reiterate that for that specific use case, Dremio will probably be making an announcement in very, very short term. So definitely follow the Dremio LinkedIn page, so that way when that announcement comes. But yeah, I mean, as far as like basically being able to take anything and turn it into Iceberg, the options you have are growing. Dremio's been growing its DML options. Upsolver just released its features regarding ingesting into Iceberg. Pretty much all the ingestion tools uh, have now options for ingesting the Iceberg. So bottom line is like the variety is out there. We do cover a lot of them in Apache Iceberg, the definitive guide. But right now, probably if you're going from Kafka to Iceberg, the Kafka connector I think is probably the most straightforward way, or without necessarily using a vendor like an Upsolver or Fivetran to do that for you. But again, the space is constantly changing.
And I have to stop here. We're like over the time. Thank you everyone for joining us today. I had to call an end to this party, but we will continue this either in London or any place soon. Thank you once again.
Thanks.
Bye everyone.
Thanks for having us.
Yeah.
Bye-bye.